Okay, this is a question about arc length in disguise. An ant is at a position governed by the vector cosine cubed sine cubed at time t, and you're interested in distance traveled as time goes from 0 to 2 pi. And there's a nice hint that's given that says that we should use symmetry. We find out the distance traveled in the first quadrant and then just multiply by 4. And so we have r of t, the position vector, is equal to cosine cubed sine cubed. So cosine cubed sine cubed, and that makes r prime of t then equal to, the velocity vector is going to be derivative of cosine cubed. What's like cosine to the third power? It's 3 times cosine squared but then chain rule times the derivative of cosine, negative sine. Second component, derivative of sine cubed would be 3 sine squared, and then the derivative of sine, chain rule would be cosine. Great. That's your velocity vector at any time t. And we know the formula for arc length is the integral from a to b is speed as the integrand, the magnitude of velocity. And so let's take the magnitude of velocity. We'll have the square root of each component squared and then add it together. And so we will get a 9 cosine 4th sine squared plus a 9 sine 4th cosine squared. Now, it's going to benefit us to take advantage of trig identity. If we factor out what these have in common, or actually just factor out the 9, and but they also have a sine squared in common and a cosine squared in common. So let's take out more than just the 9. What does that leave you with when you factor out what they have in common? Then it leaves you conveniently with cosine squared for the first term, sine plus sine squared for the second term. And we know that is 1. And so, since that's a 1, then we're just looking at the square root of 9 sine squared cosine squared, which reduces to be 3 times the sine of t times the cosine of t. Not bad at all once you make your way through it. That is what the integrand is and our arc length formula. We are going to integrate this from 0 to pi over 2 and then use symmetry to multiply by 4. So the answer, the arc length, is going to equal 4 times this integral. Symmetry. And we'll just use u substitution. We have let u be sine, du is cosine, and we'll be integrating u du. Let's go ahead and pull out the 12. I mean, pull out the 3. It already has a 4 outside. And sine times cosine. I'll go ahead and officially write out what the u substitution is. If you let u be sine t, then du is cosine t dt. Whenever you see one part of it, of the integrand, and the other part being its derivative, especially when it's exactly its derivative, then that makes things tremendously easier for you, because then what that means to us is that we're just integrating u to u. And we know that to be u squared over 2. Now we could do a limit switch if you like. When t is 0, u is 0, we'll get that by plugging into the substitution. And when t is pi over 2, we get that u is the sine of pi over 2, which is 1. So it might be beneficial to us actually to do a limit switch here. So, and go from 0 to 1. So we're going to end up with u squared over 2, or half of u squared. Let me, sorry. So we have the 12 on the outside, and then 1/2 of u squared from 0 to 1. And so the answer is 6. We've already accounted for the symmetry. That would be letter D, arc length.